Hello everyone, it's October 23rd. All right, let's do this. Find largest. All right, let's turn these off. Find the largest value in each tree flow given the root of a binary tree. Return an array of the largest value in each tree flow, each tree row. Largest value in each row of the index. Of the tree. Come on, wake up. Man, wake up. All right, so we just need to find the largest value of each row. BFS will work, right? Yeah, let's go BFS. It shouldn't be too hard. Should not be too hard. Doesn't matter. So BFS, we just need a queue, right? Queue, we're gonna do a list of tree node, right? Queue equals to new array list, okay? And list of integer res new array list. Okay, and then we're gonna say queue dot add root. It's fine. While not queue dot is empty, list tree node temp equal to new array list. Okay, and then for tree node of queue. Oh, we need a current max int max. Right, max shall equal to integer dot mean value. And then we say max equal to max dot max node dot val if node dot left, then temp dot add node dot left. Well, can do this. Node dot right. Node dot right. So we're done. I say rest dot add max. Then queue equals temp, and now return rest. All right, I'm not sure. This is the thing. I'm not sure if I can do queue equals temp. That's the thing. I think I tried it before. I'm not quite sure. Cannot be converted boolean is not equal to no. Not equal to no. Oh, I guess I can. Huh. Yeah. Ugh. Screw you, man. Root is null. I think it's the same problem. Always forget. if root is null, return nothing. Oopsie doozy. Yeah. DFS. Don't forget to check a null root. Got an easy one today, huh? DFS. Okay, let's try DFS. How do you do a DFS? Well, if it's DFS, we just need to know the level, right? We know the level. Yeah, as we go down. Yeah, we can. I think I can do DFS. Let's try DFS. So DFS will be private void DFS. What do I need? I need a tree node. Okay. And I also need a result. So list integer, right? Res new array list. Okay, so we'll go DFS. We also have levels. Okay, int level. So every time I hit the node, I'll first check, right? I'll first check. We say if res.size, right? If res.size is equal to level, then res.add node.val. Right? If it's equal, that means it's a new one. Else res.put. Now put get how do I change the value? Set level -1, right? Math dot maximum res dot get level -1 and node.val. Okay, so we handle that, and then we're gonna do if node is equal to null, we simply return. Okay, now we DFS node.left, DFS node.right. Done. Okay. And in this one, we'll simply do DFS root And then we return this, return res. Okay. Let's see. Cannot be applied to a given type. DFS, no dot left. Oh, shoot. My bad. I forgot this. Level +1. Sorry. Ooh, that was not right. We start with 0. How? That was very bad. 139. Oh, I think it's not level -1. It's level. That's the thing. It's level. Yeah, it's level. Yeah. DFS. Okay, that's it. I don't have to go through this. It's just BFS, DFS. Okay. All right, promise pool. We've done this before. I honestly don't remember. Given an array of asynchronous functions and a pool limit, return an asynchronous function, promise pool. You return a promise that resolves when all the input function resolves. Pool limit is defined as the maximum number of promises that can be pending at once. Promise pool should begin execution of as many functions as possible and continue executing new functions when old promises resolve. Promise pool should execute functions I, then I+1, and then I+2 when the last promise resolves. Promise pool should also resolve. Yeah, I think it's a race or one of those. And every time one gets out, so what do we return? Return a promise that resolves when all the input function resolves. I think what I tried last time was to see if it continues, right? Because we have to do promise race. Yeah, it settles on the first. Oh, I think it's all. Initerable of promises as. Nah, you cannot do that. You have to go the first one. Yeah, it's race. It is race. Or maybe it's any. Any of the promises fulfills. Yeah, we can use any. And I think the rest continues. How about race? The return prompt remains pending forever if it passes empty. I think we use race, right? So I'll use race because there's a bunch of functions, and I'll put the first n into it. Right, I'll put the first n into it, and every time someone gets done, we'll put a new one in. Someone gets done, we put a new one in until everything is done. Okay. Yeah, but we cannot take functions. We have to get it to be, you know, how do we get it out? How do we take a function that's done out? Because I need to put a new one in, right? I need to put a new one in. I mean, we can index it. So we just splice it out. Right, we splice it out, put a new one in. Always splice one out, put a new one in. So I need to know the index of, but how do I know that? We need to make some change to the function. So the function has to return. The function actually push to the race has to return its index. So we need to make some changes to this, right? So we need to make some changes. So here's what I think. We need to make some changes. So I can say helper function and index async, right? We'll return rest will be a wait function call, and then we'll return a index and a result. So with that, we can say func list let function list shall equal to a list of functions, right? So we do this, right? for if there are more functions than n, right? If there are more functions than n, then that's fine. N is the pull limit, so we go through the smaller of the two, right? We'll go through the smaller of the two. So for let I, or I can splice, right? Slice, right? Slice. So if I say animal slice 0, 1, 2, all the way 0 to 1, 2, 3, so I don't think it's inclusive. And bison, camel, 0, 1, 2, 3, yeah. So if I go 10, that's the entire thing, right? That's the entire thing. So I can slice it, right? So that shall be functions. If I slice it, and that will be index, right? Functions dot slice 0 to n, okay? Dot map, where each function will be helper function. Return a helper function. Wait, we need to return a function that that's better. We'll return a function, right? We'll return a function. It's async function. Return helper function, func, and index. Right. So, oh, it can be a promise, right? Yeah, I don't have to. It's a promise. That's all we need to do. Return a promise, right? So we return, this is a promise. I haven't waited yet, so it's a promise. So func list is that, okay? Then let index shall equal to n. Index shall equal to n. Okay. Then we say while index shall equal to math dot minimum of functions dot length and n. Okay. Then we say while index is smaller equal to functions dot length, right? Index is smaller equal to, because eventually index, so index shall be the next one, right? So index is the next one, so index should be equal to the length, which means we can add one more. And now if index is larger, if index is, so it's a previous one, and then we add it to it, index is equal to length, then we need to handle function list again. You know what? I don't think so. I think what we need to do is while funclist.length is larger than 0, right? Then what do? We do result, right? Const res shall equal to this. Okay. Then we say current await promise dot race. Right? That's how you do it. Promise dot race. Yeah, well, promise or race func list. No, it's not func list. It's just p list. Right? P list. It's a p list. Promise list. Right. So we erase this when we get one out. Is actually we can say const current. No, it's index I r. Right? So we get that. We say res I or equal to r. And then if index is smaller than functions dot length, plist dot add push. Right, plist dot push. Push what? Push helper functions index and the current because one will get out, right? So when you put it in, that is functions index. Yeah, that is index. But then how do you get this one out of the p list? Holy crap. I need two indices. One index tell me the index inside the p list, but the p list will change, right? It will change. Ugh. Yeah, you take it out. Then what? Yeah, who gets out? And everybody's index changes. How do we do this? Hold on, I need to take a look. What if we get foo, right? And let's do it 2 times. Do it 3 times. Yep, this one gets out first, so we have to remove it. Right? So we have to say foo dot splice. Oh, I forgot. How's the syntax of splice? How many? How many? So splice 0, 1, 2, 1, right? Starting from something. Removing or replacing existing. Start, delete. So yeah, this is to remove the last one. And then again, foo dot splice. Yeah, it changes. In the index changes. 0, 1, 0, 1. Yeah. Which means I need to return 2 indices. Jesus. So we have to have an I and a J. So I, J, res. Okay. So at the beginning is the same. Okay. The beginning is the same. So we're gonna get I, J, R. So I, it doesn't change. I is the original one. So we do that. And then we have to redo Oh, I just swap it. Ah, I see. plist.splice. No. You don't even need to splice. Just J, right? You splice, not splice, you J equal to helper I and J. Right? I replace it. I replace it with something else. Replace it with something else. That's when we have something, so we replace it. If we don't, else. Or else, if we don't, and we need to remove it. Then we need to remove it. But anyway, I'm done index plus plus. We need to remove it. How do we remove it? We need to splice it. But once we splice it, everybody after that has to change. Dear me. Or I can replace it with something that, you know, never resolve. That doesn't sound right. That doesn't sound right. I mean, your whole idea is we need to remove it. But if we remove it, then the index will be wrong. So we have to redo the index. So every time you do it, but I guess it's fine. I guess it's fine. We just, oh, it's not fine. We cannot redo. We just need to remove. Oh, if we remove, yeah, then how do we know? Gert. I mean, I can replace it with, replace it with something that's, my God, we replace it with something, take the longest to, how do you know how long it's gonna take? Yeah, this doesn't feel right. It doesn't feel right at all. But I cannot redo. I mean, you can. You cannot. I cannot redo this. Unless, no, there's no unless. This promise is already being handled. I return a promise. I get all their promises, and now I put it in, and then one of the promises come out first, and they'll wrap it around into a new function, right? Everybody gets wrapped around in a new function, and then it just doesn't work anymore. And to replace it, yeah, that's my current idea, is to replace it with something that's guaranteed to resolve very, very late. Yeah, but otherwise, how do you know which one is which, right? You don't know which one's which. I have to know which one is which, right? I have to know that. Is there something that will never resolve? A never resolve promise. Oh, I just don't call the resolve, right? I just don't call the resolve. Huh. That is actually not a bad idea. It's not bad at all. I just never resolve. So I can say, yeah, else I just say plist j will equal to new promise. That's it. It never resolve, right? This one will never resolve. I have to try. So basically we know, I just say foo2 will equal to a new promise, right? But we never resolve it. And here I say foo1 equal to a new promise. Error, promise resolve undefined. Okay, I have to define it. So resolve, but I don't call it, right? I don't call it. Yep, that is right. So I still do this. I still need to do this. My cat is absolutely bonkers doing stuff. Anyway, so this is fine. This is fine. And then index is fine. What I need to check this is res.length is smaller than functions.length, right? That means we don't have enough. And then get it, resolve. We simply don't resolve it. So this is a never resolving promise. So we just replace it. All right, we replace it. Whatever it is, we replace it. Until we're done, then we just return res. Let's see. Is this one working? Accessing an existing list node. Module exports accurate dependency. What? Cannot access index before. Oh, there's no index. My bad. There's supposed to be an index. Yeah, think it works, right? Ha. Yeah, it works. Let's put everybody in. I forgot what I used in the past. Oh my goodness. All right, so the second one doesn't work. It's -1. What? What the hell, man? What the hell? -1, -1, 199. Dude, this is so bad. The second one is the first one is 2. Second one is 5. Second one is 5. We have 3. So, which means this is, plist should only have size 3. And this index should be 3. Right? Index shall be 3. Rest is this. Where's the length? We promise plist. This is a -1? What the hell, -1? I am not sure what happened there. -1? Huh? The hell? That's console.log. plist.length. Okay, I and j. We call it once. plist is 3. I is 2. That's correct. Right? Index smaller than, I wish I actually get plist length is right. Okay, so I want index. I want a rest.length. Rest.length is 0. That is correct. And then what? And then rest I equal to r. It doesn't matter. Index is 3. Three functions.length is 3. So that's false. So the j, right? The j is the thing. J is 2. So you go to a new promise and index plus. Okay, this is actually not right. Index shouldn't plus. But that's still not right. We shall come back up. We should have a second running of this. Why is this only running once? Oh, I think I know. Because no way. No way. It gets you 3 already. Ah. That's not right. Okay, so I have to go object.keys rest.length. Because the way I'm doing it, that's the only way. There we go. That's the way to go. Yep. Yep. Okay, let's see how I did it last time. Map. You have a console.log. Come on. I'll delete it from the map. I'll use a map. Okay, I'll use a map, a wrapper. Yeah, the wrapper is the same. What? Functions index and index. And index. We put an index and then we'll do the map. We'll use map. Yes, we can use map. Current and K. And then I'll delete it from the map, right? And then we'll do the values of the map again. Yes, it works. This, of course, it works as well. I just replace it with a never resolving promise. And I have to return 3 things. I mean, we can definitely do this, right? If we do that, and you know, because we do ij, so let's put function at the end. Right, I'll put function at the end. So we're going to say I is the index in functions. J is the index in plist. Right, does I have to do this? Which is, no, alright. And this we're going to be, let's do this, await. Right. Rest, do this, plist. Shall work. I'm hoping that by doing this it'll be a little bit faster. It is slightly faster. What was the solution? Recursive helper. 2 liners. Oh my goodness. Hold on. I didn't even I think I didn't read this last time. 2636. Okay. So this is still the same idea as before. Right, this is still the same idea as before. Now we're gonna go looking for solutions. Yeah, that's not parallel. A pool. Recursive. let's see. So it's a return a promise. In progress count. Function index. Turn helper. If function index is larger or equal to function index larger equal to length. So we go beyond the function. If in progress, nothing in progress, we just resolve it. Okay, so if it's smaller, then we still have more. In progress, smaller than n. What is this helper? Oh, helper is this. We do promise count, promise. Oh, when you do promise dot then, you're not waiting for it. The promise dot then is a callback, right? So this one will keep running, and each time you run, you put a promise dot then. Each time you run, you put a promise dot then. That makes sense, right? And then every time you do in progress update, function index update, and then so you throw the first n into it. We'll all call promise.then. Yeah, they're all into it. And once it's done, we'll call helper again. Current number of promise being executed. Every time we execute a return, but this one doesn't return the actual values. This one just resolves them. I repeat step 1. Async await. Use .all. Evaluate next. Functions.shift. What's this? What's shift? Removes the first element from an array and returns that. This method changes the length. Remove the first. Why are you saying shift? Why don't you pop? Wait, hold a second. Hold a second. What? evaluate next. It's async function, okay? And then I say if at exhausted functions return. Otherwise, we grab a function, wait on it, and once it's finished, we'll evaluate the next. So whoever gets done first will grab the next one. Does array have pop? It does. Pop is the last element, right? So I can just pop. Yeah, you put n of them. Oh, map. Oh, this is so good. Yeah, it makes sense. Recursive calls itself and waits for its own completion. Any function finished, the next function in the queue is processed. Oh yeah, that's true. My goodness. But hold on, let me just try to see if we can. Yeah, we're not gonna do that. We will. Let me try it again. So what do? We have eval next is an async function, okay? And this function will say if functions.length is equal to 0, then we just return, right? Otherwise, we'll say functions.pop await function await eval next, okay? And then we say const plist should equal to array n dot fill dot map whatever, doesn't matter, eval next, right? And then we'll return promise dot all plist when all of them gets evaluated. So when we do this map, yeah, this map basically says we'll put all of them, because this one returns a promise, right? This one returns a promise. So we have all of them, because each one you call it, You call it, something gets removed. You call it, something gets removed, right? So you call it, and then you will promise all of them, and then you get one evaluated, and will immediately evaluate the next one. All the other ones are continuously being evaluated. Oh, but this doesn't return the final value, but it's okay, right? It's okay. So this is the second method from the official solution. Very good. The recursion is really, really good. It's not right. Oh, we go right to left. Oh, that's why I have to use first. Ah, because it has to be, oh my goodness. My God. Well, what's the complexity? Array first complexity. Push pop shift. Shift is on, right? Nah, I don't like it. I do not like it. I is equal to function. Let's call it index. Okay. Functions.length. Okay. Functions index plus plus. Right. And then yep, I think this one is better. We do not use array dot first to avoid its on complexity. All right, let's see. Working? Yep, it works. All right, we have one more thing to go through, which is the last one. Two lines. Optional chaining on the function call. This immediately returns undefined if this is null, or undefined. Without this an error. Oh my goodness. I've never seen this before. What the? Promise chaining. So dot map, I'll do that, and dot then. Now what does this one return? think this one dot then returns a promise as well. Right? Then returns a promise as well. A new promise. Yeah, it returns a new promise. So you always return a promise. Oh, I don't like this. I like this one. I like this one a lot. But a new one. Like this is the recursion just means this one will constantly get the next one, constantly get the next one. Yeah, the recursion is really amazing. Yeah, that's a good explanation. Oh, did I like this one? Wait, hold a second. I upvote this. I upvote this. So I read this already. Yeah, I don't like this. Too esoteric. This is good enough. I like this one. I mean, you can combine these two into one line, and these two can be in one line, right? I mean, I can do this. If you really want to shrink, right? We can shrink. Can't shrink the rest, but I can definitely shrink this, right? If I really want to say shrink. It's not much, right? It's not much. And you can say I just pass this function by itself, right? So it's like 1, 2, 3, 4, 5, 6 lines. It's not too bad, right? It's not too bad. Ooh. Oh, should be another one. Fewer lines. All right, that'll be it. I don't think I want to keep going. I think the key, right? The key is just to realize we can do this recursion. This recursion is really nice. When one promise gets resolved, immediately get the next promise. Immediately get the next promise. That's really nice. All right, that will be it for today. I'll see you guys tomorrow. Adios.